My name is Nurul Nadira. BT Mode Hilmi will start the presentation introduction of the report. Railway projects are very important for the economy and for getting people and goods where they need to go. Like other infrastructure projects, railway construction projects are big, take a long time to finish, are very complicated, have difficult site conditions, require a lot of money, and involve a lot of different people. The electrification of double-track project EDP, a project the Malaysian government undertook, traverses the 4 states of Perak, Penang, Kedah, and Perlis on the country's northern peninsula. The project entails the installation and electrification of a 329 kilometers double track next to the already existing single track that connects Padang Besar in Perlis to Ipoh in Perak. After being put on hold in 2003, the project was picked up again in 2007 and awarded to the MCC Gamuda joint venture. The initiative includes Perak, Penang, Kedah, and Perlis as its 4 covered states.
Hello everyone, my name is Noor Audra Layli binti Mohd Sabri. Next I'm going to talk about brief project for this case study. This electrified double-track project was proposed in 2002 as a continuation of the double-tracking and electrification project between Rawang and Ipoh, a consortium consisting of the Indian Railway Construction Company, DRB Hicom Berhad, and MRail SDN BHD was to manage the 329 km northern section between Ipoh and Padang Besar. On December 14, 2007, Gamuda announced that it and MMC had received a letter of acceptance dated December 13, 2007 from the Malaysian government accepting the joint venture's proposal to carry out the electrified double-tracking project from Ipoh to Padang Besar on a design and build basis for a lump sum price of RM1.485 billion. The works include the design and construction of infrastructure and system works for the project, which must be completed within 60 months of the start date. Next, I'm going to list parties involved in this project. Every project has its own stakeholder or parties involved to ensure the project runs smoothly and successfully. In our case study, the client for this project is Kereta Tanah Melayu Berhad. Architect is NRY Architects SDN BHD. Consultant is JTK Consult. And lastly, the contractor who win in this project is MMC Gamuda Joint Venture SDN BHD. Next, I will pass to the next presenter to explain more detail.
The figure shows the components of electrified track system. It is the same components as used for EDTP Ipoh Padang Besar project. The components are ballast, sleepers, rails, fastening system, penroll rail clips, turnouts, gantry, catenary wire, contact wire, isolator, and mesh.
Assalamu alaikum. My name is Nur Farzana Farhan. In this video, I will be explaining about the construction process of railway construction. First step is the pre-construction activities. Before building a railroad track, some preliminary work must be done. Subgrade drainage and material preparation are prevalent across all of the activities. To avoid waterlogging on the railroad, a system called subgrade drainage is used. It is very simple for water to wash away the subgrade, the roadbed, and the slope of the railroad track. The subgrade disease will develop if the subgrade drainage measures are not adequate. Drainage must be installed before the track can be laid. In some areas, it primarily uses attenuation ponds, carrier drains, and drainage pipes. Before laying track, there is still work to be done in terms of preparing construction materials. Steel rail, rail fasteners, railroad sleepers, and some construction machinery are examples of common materials. The main focus of preparation work is ensuring the integrity and complement of all materials. It is decided to locate a logistics station as close as possible to the railroad construction site. There are storage facilities for every track material required for railway construction. Concrete sleepers have been placed carefully. Later, these sleepers are loaded onto the unloaded tie cars, which are then transported to the track installation machine. On another occasion, rails are attached to the sleepers that have already been advanced and are currently being machine-laid on the roadbed. Then, bottom ballast is laid. Firstly, according to the design, the bottom ballast thickness will be adjusted. A double track layout is used for the main track. Medium-grained sand is used as bottom ballast. The railroad sleepers should be spread out. The sleepers must be placed evenly on both sides of the railroad track. The railroad sleepers are manually placed on the track. The alignment between the center line of the rail track and the railway sleeper's central point must be maintained. Bottom ballast is brought to the track and distributed evenly according to the schedule. Then the ballast will be compacted. Ballasting work involves a variety of tasks including moving, unloading, spreading, lifting track, lining the track, tamping, and shaping the ballast bed. Among them, special automatic ballast unloading vehicles are typically used for the transportation and unloading of ballast. Then, laying of rail sleepers. When building a railroad track, a machine lifts a concrete sleeper from the back container, moves it to the front cantilever, drops it into place, moves it into position, and then sets it on the ballast. In order to complete the railway sleeper laid, the machine advances a section of distance after each railway sleeper is laid. Iron plates, track bolts, rail clips, and other railroad fasteners will be pre-reinforced on the rail sleeper at this time. And they will be reinforced once more after the rail is installed. Then, anchorage installation. Anchorage refers to the method of fastening a railroad spike to a rail sleeper. The following materials are needed for this procedure: sulfur, sand, cement, paraffin, and screw spike. Next, laying of steel rail. Track laying and rail apolegamy are the two main components of steel rail laying. The process of rail apolegamy is essential to track laying. Each rail's length can be measured and used as the basis for rail apolegamy. Rails with the same length deviation are appropriate for use. Rail laying start from the rear end of turnout. The location of the insulation joints can be used to calculate the length of non-standard rails. Steel rails should be moved by the monorail vehicle and manually raised to the rail ditch. When the steel rail is in place, use the rail fastening system and rail parts, such as the rail joint, to join it to the railway sleepers. After that, top ballast is laid. Top ballast laying entails laying ballast on the track and resurfacing it to achieve the desired outcome. Top ballast laying follows a set procedure that includes spreading ballast, transporting ballast, lifting track, lining track, filling track with ballast, tamping, and finishing track bed. For the initial laying of top ballast, the track will be covered with ballast, then lifting each rail into position and padding it with ballast, keeping each steel railing point at the same level. Then track lining is done. After that, the road's center line will be changed, smoothing the straights and curves. Then tamping takes place. Once the top ballast is ready, the tamping machine starts to work. The tamping continues 3 or 4 times. Lastly, filling the crib with ballast. Lastly, the installation of rail anchor and rail brace. To keep the track from crawling, rail anchor is used. With the help of rail bolts and nuts, the rail brace is attached to the steel rail. Both the rail anchor and the rail brace are intended to secure the steel rail and guarantee its safety. Thank you. That's all from me.
Electric traction power is type of construction used. For the introduction, in the last 20 years there has been a rapid acceleration in railway traction development. This has run in parallel with the development of power electronics and microprocessors. Next, power supply. The electric railway needs a power supply that the trains can access at all times. It must be safe, economical, and user-friendly. It can use either DC direct current or AC alternating current. Third, shoes and shoe gear. The simplest is what is called top contact, because that's the part off rail upon which the pickup shoe slides. Here is also a side contact system. Side contact isn't much better than top contact, but at least it is less exposed. Next, grains with only one pantograph, but on trains which use shoes, there are always several shoes. The contact with the overhead wire is not normally broken, but third rail must be broken at junctions T low for the continuity of running rails. These third rail breaks, or gaps, as they are called, can lead to loss of power on the train. Last but not least, AC or DC traction. It doesn't really matter whether you have AC or DC motors. Nowadays either can work with an AC or DC play. You just need to put the right sort of control system between the supply and the motor and it will work.
Hi, my name is Wan Mohamed Shamil Hazik, and I will be talking about problems encountered during the construction process and steps taken to solve all problems.
First problem is difficulty in obtaining component parts. Even when it is necessary to replace particular component parts during inspection, a significant number of electrical components are not produced in South Africa.
Imported components require time to clear customs. Some of them could take several months to acquire.
As time passes, manufacturers may cease production of certain component parts.
Therefore, in order to maintain the operability of rolling stock, the railway operator must cease utilizing certain train cars and remove their components for use in other cars.
Some imported components may be defective.
Next problem is drill and blast.
The drill and blast method back to the early 1600s and is suitable for both weak and strong rock formations such as chalk, clay and marl.
It is useful for tunnels with non-circular cross-sections and shorter lengths, for which a TBM is deemed inappropriate.
Drilling blast holes, charging boreholes, tamping, fume extraction by ventilation, mucking and support installation are all components of the drill and blast method. The primary downsides of the drill and blast approach are the blasting-induced vibrations and shockwaves. These factors make it an undesirable option in densely populated metropolitan areas.
The downsides of the drill and blast method include severe noise, fumes, dust and flying debris.
Consequently, both personnel and equipment must be removed from the operating area.
Last but not least, effluent from sewage treatment systems. During the operational phase of the project, the discharge of treated effluent from the sewage treatment system SDS will have a significant impact on water quality. It is unlawful to release untreated sewage and sullage from passenger train stops, maintenance bases and staff quarters.
Instead, these must be directed into an SDS. Priority option for sewage management for this project is to connect and discharge into the closest existing sewerage line. In the absence of an existing sewerage line, all sewage and sullage from passenger rail stations, maintenance bases and staff quarters shall be sent to an SDS constructed for the appropriate population equivalent to accommodate the passenger flow.
To conclude this presentation, we are discussing a few types of railway method of construction and the construction process of this project. For this project method, there are using catenary system. Method of construction in this project is that special track laying machines are required. The track material carried by the material in the first sort of machine. The track material carried by the material in the first sort of machine. The train arrives at the railhead and is set in the desired position using a projecting arm or installed on the truck nearest to the railhead. Other than that, the important part, which is the construction process of the project, must be the suitable process for electric railway. Thank you, that's all from us.
Thank you for watching.